Oops, that is the sound of we got something wrong. Hi, hello, Pat here. As we've said before, we are allowed to be wrong on this show. However, that means that we also hope to correct ourselves and our mistakes and make that clear in the show where we can. Throughout this episode in particular, we're going to be talking about benign versus malignant tumor samples from biopsies. I, repeatedly and incorrectly, call them benign cancer samples, which isn't a thing. Benign means non-cancerous. So please excuse this word snafu on my part, and remember our warning at the top of every show that this is just a podcast and not a primary source of information.
This podcast sometimes uses strong language, and it may cover topics that require viewer discretion. Also, it's a podcast. It's not a primary source of information. If you'd like to follow along visually with the show, or read any of the papers we talk about yourself, you can find all of those links and more at ridiculousresearchreview.com.
Well, that means it's time for science.
It is time for science, and you know what we start with? We start with things that scientists have found. So, today's scientist find comes to you from McGill, and it is, scientists find squirrels can survive a fall from any height. At least,
I fucking love this story so much.
It's so good. It's so good.
Yeah. Turns out squirrels don't take fall damage. They're too small.
So it's a combination of things. So, as the adage goes, it's not the fall that kills you; it's the sudden stop. That suddenness depends on weight and depends on drag. And when you have a big fluffy tail and the ability to put your legs out, the drag can be really high, and they don't weigh a lot, so they can just bounce off the ground at a speed.
They're small and they glide.
And yeah, some of them do. Some of them fly. It's crazy. My favorite associated comment with this is that the only way to kill a squirrel by dropping it is to drop it from orbit, because it will burn up on re-entry.
Wait, is that in the paper, or is this just another saying that you have?
No, that was it was a comment somebody else had on somewhere online.
So one of these science freaks forums? What is wrong with you people?
Y'all are on the wrong parts of Blue Sky, okay? Blue Sky is where all the scientists went, and they're funny people.
Anyways, who are we and why are we here? I thought we were done.
We are not done, because I have yet another paper.
Oh my
Hello,
goodness.
And welcome to the Ridiculous Research Review. I'm Pat Brennan, technical director, professor, sometimes game designer, depending on how I introduce myself. Please tell me about y'all.
I am James Lynch. Sometimes
You owe me like $200.
How
really
are you
annoying
still getting it wrong?
by these annoying fucking people that I call my friends. I am Dr. James Lynch, PhD, PE. All that means is I did a bunch of school and then a 9-hour test, okay? and I wrote a couple of papers. Oh man, the PE exam sucks. If anybody else out there has to take the PE exam, I feel for you. And if you don't have to take it, don't do it. Nobody needs that unless you're a civil engineer, in which case you can only be employed if you take the PE. But that's the only reason to do it. Don't ever pay for it. The exam sucks. Anyway, Edie.
I am Minister Edie Churchill of the Universal Life Church,
right.
and I am currently holding James's marriage license in my hand.
Oh my God! Okay, totally unrelated to the podcast. Edie signed their
James
name
is married
so
now.
bad. I'm married now. Edie signed the paper so bad that they had to send it to Massachusetts from California.
No, that's not true. They just could not read that my 2 wasn't a 7, and that's fair.
That's fair.
The more important part was that James's family did not put the cities that they were from.
No, they didn't.
Doesn't seem important. I I forgot that this happened. I forgot that you've leveled up since we last recorded. That rules.
I have
That's
leveled
right.
up. I am now a minister.
That's cool.
My wonderful officiant. I'm also now married since we last recorded. Crazy.
Wow, brag about it.
Yeah, I did it.
It was Edie's doing, and Pat just facilitated everything else about the wedding.
We don't need to get into my spreadsheets. It's fine. Let's do. Let's do science.
Yeah, let's talk
All
about
right.
it.
Okay, can you all see that?
I sure can.
Yeah, I definitely can. That looks like cells. Looks like cells.
Interesting. It looks like a cross section of a pomegranate to me.
It does look
Kind
like
of.
that,
Yeah, it does kind of look that way. Yeah. So, James, you're pretty close. You're right on the money. You're not pretty close. These are definitely cells, and if you'll notice, they are divided into two categories. Right? There's like two groups of 9 images, and each of the rows has. I'll just tell you, zoom magnifications, right? So we have like 4x, 10x, 20x, right? Which is funny because as I brought this up, I was thinking like, I don't actually know what like 4x means on a microscope. Do you, James? Like, do you know what that mathematically equates to?
It's 4 times the size with the normal eye, basically.
Cool.
So like this is 4 times larger than if it were, just from a normal camera or just if you're looking at it on the table.
Cool. Thank you. Yeah, I didn't know that.
Yeah.
Yeah. So anyway, they're divided into two groups of 9. Would either of you like to venture a guess as to what the difference between these two groupings is?
It is tough because it does look like just a bunch of splotchy purples and pinks.
It is tough, and that's kind of the point. So what you are looking at, one of these pairings shows a bunch of benign, cancerous breast cells, and the other shows a group of malignant cancerous cells. Because a little bit of a bummer. We're starting on the topic of cancer. That's what we're looking at.
Wow.
And specifically, we are looking at samples of biopsies, like I said, of breast cancer. And when you go and you have a biopsy done and you have like the doctor look at this, like they will often take the biopsy, they will send these samples out to a lab, and it's going to be a doctor's job to identify, of course, whether or not it's a malignant or a benign cancerous cell, tumor, etc., so on and so forth. Now, there's different things that they look for.
Just to pause for a moment, can you clarify what is a malignant versus benign? My understanding has always been a benign tumor is one that's just kind of there. It's not really growing. It's not going to metastasize in any way.
Yep.
And malignant is that
Malignant.
the term? I wanted to say malevolent, which is also true.
Also
but,
true.
is like one that would potentially metastasize elsewhere and is actively growing.
To my understanding, you nailed it.
Is that
Cool.
Now,
okay, cool?
My understanding of that is cursory because we're not going to delve too far down into the cancer side of this story, which is great because that would be a huge bummer. And also, hey,
It would.
I'm not a trained doctor in any way. You shouldn't take my, specialty belief responses on that.
And I am the wrong kind of doctor. Do not fucking
You're the wrong kind of
ask
doctor.
me about
Yep.
cancer.
Yep. For your reference, though, the ones on the right in this image are considered malignant, and the ones on the left are considered benign. And I mean, you can hit like right on the nose there why this takes a trained professional to look at these things because. Us jabronis looking at these things right now, we literally can't tell the difference between these things. Now, there's things that, I know that you would look for, right? There's like cell shapes and, the transparency of things. We're looking at artificially colored cells. That's part of the biopsy process, is they dye it so that it's easier to see. But it takes a lot of training and a lot of work to do this. And it's, these labs' whole job basically, or most of their job is, and you get biopsies for other things, but to get these samples, to look at these samples, and to diagnose these samples. And obviously, that's a lot of effort. That's a job that is probably, it becomes dull. It becomes stressful, right? Just to look at these things over and over again. You go a little bit cross-eyed. And there were some interesting statistics from this paper that I learned that for what is considered the trickier forms of diagnosis here, with a trained doctor, you might have something like 85% success rate, because there are versions of this that would have some indicators but not others, or the indicators would be hidden, kind of a thing. So this can be quite difficult. Now the ones we're looking at, to my understanding, are easy ones to tell the difference between, but obviously we still can't tell the difference, right? So what do we need?
And hey, I mean, 15% incorrect is still pretty bad when you're talking about cancer.
It's still pretty bad.
Yeah.
So what do we need? We need something or someone better, someone that we can train to help us look at these cancer cells.
That's a pigeon.
That's a pigeon in a box.
That's a pigeon.
That is a pigeon in a box. That's a pigeon in a box. There's a wall on the box.
Yeah. Hey,
that has a TV.
As far as that pigeon is concerned, it is in a movie theater.
Yeah, it is because this is maybe a 1 foot cube steel box with one side removed. One side of the box has a picture of the cancer cell on the TV, and
in the center of the box
is a pigeon.
It's a pigeon.
A pigeon.
Is a pigeon sitting on a grate, and
it is.
There's maybe you can tell us, is the grate just because they don't want the pigeon walking around in its own poop because they keep the pigeon in the cancer box?
Yeah, I'm pretty sure that it is a cancer. Yeah, that's pretty much for sanitary reasons, as far as I can tell.
Oh, cool.
Now, may I further hypothesize?
Oh, please.
Because next to this box is a contraption that it can only be described as a contraption. And on the top of this contraption are two small containers that appear to have very small pellets in them, which I can only assume are treats for when the pigeon gets it right.
Oh, buddy, you nailed it.
Oh,
yeah, I mean,
my God.
Nice.
This is a picture worth all the words. This was a picture that I saw, and I said, that's a whole episode.
Oh, my goodness.
We're teaching pigeons to diagnose cancer. That's what we're doing here. Or specifically to identify malignant breast cancer cells versus benign breast cancer cells. And so, yes, I mean, you've surmised most of it exactly. We have a little pigeon in a box. It has a series of treats. That screen in front of it is not just a screen. It is, in fact, a touch screen that allows the pigeon to make inputs and to be trained and to determine whether or not the cancer cell that it is being shown is malignant or benign.
Pat.
Yeah.
We're getting pigeons addicted to smartphones, too?
Well, now, hold on, James. I want you to think about this a different way.
Oh,
because there has been a huge trend in pigeon sentiment where people are more and more upset about the fact that humanity domesticated the pigeon for message carrying and for other sorts of jobs, and then very, very quickly abandoned the pigeon after having bred out all of its evolutionary wilderness. So you could think of this as a pigeon re-employment program.
Oh,
yeah,
I like
you really
that.
could. And
like
Edie, buddy, I
that.
really want you to hold on to that sentiment, because I think that's important, right?
Excellent.
We should frame this as the pigeons that we've abandoned. We're getting them jobs back. We're bringing them back into the fold, and we're going to help them.
This is a humanitarian effort.
A humanitarian effort for pigeons. Why are we doing this? Well, I mean, as Edie just said,
To reemploy the pigeons.
pigeons are the perfect bird.
We have to re-employ the pigeons, and we still don't really understand how they're able to just fly wherever they want.
Yeah. So
They're so bad at making nests.
I did put this slide in here just for me. I love these dumb little bastards. I think they're so good. We, as Edie mentioned, we did in fact domesticate them. They fully forgot how to make nests, and now here in New York City, I see them all the time. You will see a pigeon quote unquote nest, which is just really a collection of loose sticks and straw. Sometimes literally drinking straws, that they have put an egg lovingly next to, and maybe it will hatch into a pigeon.
Pat, is it the most New York thing about you that you you love pigeons? Is that the most?
I don't think most New Yorkers like pigeons. I think that they consider them rats with wings. Many people I have known through my life are like afraid of them.
That's so silly.
I have an enjoy-hate relationship with the pigeons for sure, because while I do enjoy them, there's like the pigeon guy in the parks that like gets everybody to, like, you know, it gives you bird feed and the pigeons all land on you, and that's a really cool way to get bird mites, which I only know about because some of my undergrads once brought them into one of the scene shops I was in, and my scene shop was infested with bird mites, and we had to get it exterminated, and it was bad.
That's fascinating and awful.
Yeah, yeah, you really should not hang out with these guys. Yeah. So anyway, the paper, it's funny because the paper doesn't bring up the story of, the re-domestication or the fact that the pigeons were sort of like brought in and then abandoned. Like that actually isn't in the paper at all. But I think it is worth noting, Edie, so I'm glad that you brought it up even before my slide got here. No, why are we really doing this? The 4 questions that our scientists wanted to have answered are as follows, and I will just read them off this slide. Question 1. Could discrimination between benign and malignant pathology and radiology images be taught to pigeons entirely without the benefit of verbal instructions generally provided to human observers? So 2 things to pause on in there. So we're going to be looking at benign and malignant pathology. That was sort of that first image you saw. Mm-hmm. We're also going to look at radiology, which is sort of like mammograms and more of like those black and white scan images that you've probably seen before. Uh-huh. And I do really love this note where it's like, we can't give the pigeons verbal instructions. They just can't take them. They don't understand human speech. We can't teach them that. So we're going to see if we can teach them otherwise.
Oh, man.
Question 2. Could pigeons go beyond mere memorization and demonstrate generalization, i.e. perform accurately when confronted with related but novel stimuli? So they don't want these pigeons to just remember images. They want these pigeons to learn to identify the traits and characteristics that make these samples malignant versus benign, and see if they can teach these pigeons to identify the cancerous cells.
I love this. I love this so much.
I knew you would.
Because the thing it struck me immediately was, depending on the results of this paper, if a bunch of med students fail a future exam, their instructor is going to tear into them and say, literally, pigeons can do better than this.
A pigeon could do this.
3. How would pigeons perform when given image discrimination tasks that are extremely difficult even for skilled human observers? So I sort of mentioned that before, where like they're going to look at some of the tougher to diagnose samples and see if the pigeons can actually tell the difference between those, or even if they get close to like, trained humans and how well we can do them. And 4, if the birds were successful...
Gotta say, I'm rooting for the pigeons.
Absolutely rooting for the pigeons.
I want the pigeons to do higher percent. I want them to do better.
I've created an energy in the podcast. And it's a real underdog story. If the birds are successful, question 4, could such skills have any practical utility? Which I do love that we acknowledge from the beginning. Is this useful at all? Is a question that we have. Okay.
Can I say real quick, that's a lot of questions to pose at the beginning of your pigeon study that I know, as somebody who's written a paper before, you didn't ask all of those questions at the beginning.
No, they did not.
So, for anybody reading papers in the future, if you make a bunch of questions like that seem to follow from the first and second and third questions, that means they are telling you, hey, this shit worked, and then we kept going.
So how are we doing this? All right. The way we're doing this,
we're putting pigeons in boxes.
I've got a video. You've seen the contraption already. I'm gonna play this video for you. I'm not gonna play the whole video because it gives away a little bit at the end. So I'm just gonna play the start of this video.
Well, you begin by putting the pigeon in a refrigerator.
You don't. No refrigerators involved. Okay. And I can narrate here for a little bit, just for viewers' sake, kind of a thing. So we have our pigeon in the box, which we saw before. We're going to start by looking at the pathology trials, which are those images I showed at first. The first thing they do is they play a little white image on the screen just to get the bird to peck the screen to acknowledge that it's looking at the screen. And they want a couple of different pecks just so that they know the pigeon is looking like intentionally. The pigeon has learned, I need to pay attention to this thing. Once the pigeon is pecked enough times, a blue and yellow bar appear on the side. And that's how the pigeon is going to input its answer. It's either going to pick the right or the left side. And in the training modules, if it has picked the correct side, it is rewarded with a treat. And if in the training modules, if it picks the wrong side, it gets no food and it gets shown the next image. Or actually, I think it gets shown the same image until it makes the correct choice. So over time, these pigeons are learning to identify, I should click the yellow button when I see a thing that looks like this, right?
Honestly, I'm looking at this. Whatever the treats are, they must be great, because this pigeon is real excited.
This pigeon wants them.
This pigeon wants a treat.
Yeah, man. One thing I should note that was in the paper was that these pigeons had been trained and used in previous studies before. So presumably these birds already understand sort of like the treat reward process, and maybe even understand that like this box contraption gives them treats if they do the right thing. So like they have already been trained to know, like, I should interact with stuff.
When I'm in the box, I do the thing.
Yeah. And now that we're looking at this specific study, now we're specifically teaching these birds to look at these images to try and tell the difference between them.
This is great.
It's very good. So a little more details on these trial studies, all right? So we are training 8 pigeons in total, and they're being trained across several tests and experiments, right? So like all 8 of them get trained together at first, and again, they get shown those slides at the beginning, but I will say the researchers already know that they need to be able to prove that like these aren't just like random guesses or that the birds aren't just memorizing images. So for example, half the pigeons are trained on the dyed images we saw in the beginning, and the other half are trained on these monochrome images I'm showing on the slide now. That's those middle set, where it'll be like the same types of slides, but the saturation has been pulled out of them and they have a single hue so that they can like make sure that like the birds, you know, aren't just, you know, I don't know, picking a pretty color or something like that. I mentioned the training process where they pick an image and then they get a treat if they get it right. They then have a separate thing. So they do like 144 training pictures in a session, so like a day with the bird. So like they'll take the bird, they'll do that 144 times. It gets a treat if it gets the right picture. They then do like an additional like 20 images or so. It changes a little bit per sample because they look at different types of images and they have different sets of them. It's not really important, but the point is that they then enter what's they're calling like a testing phase, where they're like, okay, now pigeon, we're going to see if you've learned things. And so they'll show them like 40 more images, and in those images there will be images that they have seen previously in training over the last few days, and then they will also show the birds new images. So they will see like totally new biopsy samples, or they'll see like a same image that they've seen before where the image has been rotated, or like the saturation has changed on it, or like the zoom scale has changed on it. They'll change something about it, and that's what they refer to whenever we hear like novel stimuli. That's when the bird is seeing something new and they're trying to see if the bird can get it right?
Yep.
From there, they run more tests and they sort of subdivide this, and we won't go into all of these, but like you can see up above, you see those black and white, that's the mammogram radiology kind of scans. And they also train the birds on those, and they show them those things. But the process is the same for all of these things. What's changing between each research is the types of images we're showing. So we do different zooms, we do different color saturations, we do like compressed images of various kinds that have like various visual degradation. We do different types. We do biopsy versus radiology, all kinds of different things. And yeah, I mean, that's basically the whole study. Is just we train the birds on a set of images, and then we give them tests, and we do that for a couple of weeks, basically, right? So how did the birds do? I know that you've been wondering. I know we're rooting for the birds. Yeah,
you've been holding this information, and it's the only thing that's important to me is, did the birds do better than people?
Can I also pause for just... I'm sorry, we will get there, and I have to know.
Yeah.
But I wanted to point out...
How dare you?
That everything you're describing as far as, like, data processing, making sure that you're not, like, you're showing novel images, you're changing colors and saturation and all of that kind of stuff. This is exactly the way that you train, like, some kind of machine learning model.
Hey, buddy.
This is called supervised learning.
Yeah. Why don't you take that, and why don't you just slip that into your back pocket for now, because we're gonna come back, and you're already getting. I love you. You're already getting to the big picture talk at the end of this here paper.
If the birds are training AI, I no longer like them. So
how do the birds do? It turns out the pigeons are really bad at reading radiology.
No,
they're absolutely terrible at it.
No, they're 50-50. No,
They train the birds. They train these birds for 80 days, looking at these radiology readings. And what you're seeing there on the left, the like 60Y, 42Y, that's the code names or the indicator for the individual birds. So we're looking at each bird's training regiment over the course of 80 days, and we're seeing then on the right, sort of like how they did overall. And it's pretty horrible, as James mentioned. Their very best bird barely gets up to 80%. Now, it is noted that I want to say that these were considered some of the more tricky images to do, and so like doctors I think got something like 85% plus kind of a thing. So like
Gotcha.
the birds didn't do they did way better than a bird reading a mammogram should have done. How
Sure.
about that, right?
Like,
Better than you would think a pigeon should do.
13Y, or I'm going to say, I'm going to pronounce that 13y. 13y did great. 13y
did great.
13y got like 80%, at least on the training, although during testing, just 50-50 is not good. 13y, I'm sorry, friend. I'm sorry.
No, but so to be fair, 50-50 on the testing, that's like when they were learning. That was like the first time they had seen those images. So you expect all the birds to start at around 50% and get better over time, which, to be fair, all of them do. They start terrible and they do get better, right?
Yeah.
And like that dotted line, that 50% is important because they bring that up. That's the random guess.
Yes.
Sorry, can you repeat that? That second graph there is showing over time how they did, not per bird. So 13E is a time measurement, not a name of a bird.
13E? No. 13E is the name of the bird. 13Y is the bird. So on the right, that's each of the individual birds. That's just in bar graph form, basically, and that's all of their inputs averaged together. And so, like, that's their total score in training and total score in testing. And one of the things that they do mention at this point is they think that, like, you see some of these birds that in training were, like, at 80%. They're pretty sure that the birds were just memorizing the images. Because the testing was the one that really matters, where they're seeing new information. And all of them are... the best is at 60% when it gets to testing.
Yeah.
And the worst...
Yeah. So best bird, 60 years before the Battle of Yavin, only got to 60%.
Yes.
Right, exactly. And poor 75B gets this lovely quote in the paper. One bird never managed to achieve statistically greater than chance performance.
Oh, boy.
they rag on
excellent.
this. Like, you dumb pigeon, you couldn't read a mammogram. Idiot. Dumb bird. But
poor 75B.
With no instructions.
I love you, 75B. You can stay with me.
But we didn't just look at mammograms, did we? We looked at a whole bunch of samples. And let me just bring it all the way back home for you. Pigeons were shockingly good at histopathology, which is looking at biopsies.
That's so weird.
And it's something to do with, like, the images, like the difference between, how a mammogram appears, right? Where it's like there's less defined images, or defined edges, I should say, right? Like, it's blurry. There's like a three-dimensional depth to it. Maybe these pigeons can't understand. They don't actually speculate on this too much in the paper, but like if you look at the images and the difference between a biopsy sample and a radiology sample, they look totally different.
Yeah.
And you can kind of see why the bird brain might, be able to parse one and not the other. And what they find is that with the biopsy samples, the birds aren't just memorizing the images. They are actually, it seems, learning and are able to actually successfully identify, in general, I think, across all the studies, like slightly worse than humans are, but not significantly worse.
That's crazy.
It's crazy, and if you extrapolate it a little bit, like, the salary of a doctor is a lot more than the pellets of a pigeon. You know what I mean? And, like, they will make a point later on where it's like, I was mentioning at the beginning, a doctor sitting down and being asked to look at, like, 400 samples a day is going to go crazy. Like, that is, like, stressful, boring, terrible work. But a pigeon doesn't care if you show it 300.
Pigeon get 400 treats?
Exactly, right? Like, the pigeon is jazzed about it. You saw how quickly it was tapping that screen. It wants those treats. And so, again, another wonderful quote here. We found pigeons to be remarkably adept at several medical image classification tasks. They quickly learned to distinguish benign from malignant breast cancer histopathology at all magnifications, a task that can perplex inexperienced human observers who typically require considerable training to attain mastery, although the examples shown are easily classified by a trained pathologist. Starting with the low magnification, those are the 4x examples, Pigeon's accuracy increases from 50% correct, which is just random chance, on day 1 to nearly 85% by days 13 through 15. So, that's honestly, crazy. Not that long.
That's pretty impressive. 2 weeks of training.
2 weeks of training, and these birds are pretty consistently doing these things. And we're individually looking at the birds, right? Like, each of them has, like, about an 85%, right? And you can see, again, just on these graphs, just to show it out kind of a thing, like, top left is sort of like an average of each of the individual birds' scores over time. Top right, we again see that bar graph where we're looking at their training success regimen versus their testing. And then there's different graphs for each of the tests they do. I specifically pulled out the magnification one, but again, they did it for, like, saturation and different things, right? So, like, we're looking at the one where you can see plotted on here is, like, the samples at 4 times magnification, 10 times magnification, 20 times magnification, and the birds did great on all of them, basically. They had a little more trouble with 4x, but maybe because the details they were looking for weren't there. And again, they did their due diligence, right? Like, there's novel images in the testing, right? Like, so specifically this bar graph is looking at, in this test, they showed them rotated images. So, like, the birds couldn't necessarily just memorize the images, which the scientists are pretty sure is what they did in the radiology sample. I say pretty sure because, you can't ask the bird if it memorized the images or whatnot.
Right.
But it gets more wild than this, because we're talking about the individual birds. And then the scientists had a thought. What if we flock sourced? Their words, not mine. What if we took all of the birds together and we essentially let them, like, vote with their choices? What was the accuracy rate then? And, again with a quote, when a cohort of 4 birds was shown the full set of uncompressed images, the resulting group accuracy level reached an amazing 99%.
That's...
Which is...
Pigeons together strong.
That's wild.
Which is astonishing. just
yeah, that's unbelievable.
Unbelievable, right?
That's 4 birds.
That's 4 birds. Yeah.
So what you're telling me is 4 birds are smarter than a doctor?
They're certainly more accurate. When
the next time I'm feeling ill, I should go and talk to the pigeons.
Just come on down to Central Park with me. I'll take you to my bird guy.
You just show them a weird rash and have a few peck of you, and then you're like, well, I guess I need to go get some cancer treatment.
Yeah.
Oh my God.
What is this study all for? I'm going to read a quote here from our scientists at the end, just because, again, they've done it better. They've said it better than I could. But other animals with special perceptual skills have been proposed as frontline diagnosticians. For example, dogs sniffing out prostate or ovarian cancer, or giant African pouched rats detecting tuberculosis. We are not, parentheses, yet, proposing such a role for pigeons.
Yet.
Instead, we have shown that pigeons can be effective, tractable, relevant, informative, statistically interpretable, and cost-effective medical image observers. Their performance on visual discrimination tasks might prove useful in guiding basic vision research into future saliency, and could play a key role in the development of computer-assisted medical image recognition tools. Now, James, that's the thing. We're going to talk about that in just a second. I do want to just point out, so this paper is Pigeons as trainable observers of pathology and radiology breast cancer images. This is done by Richard Levinson, Elizabeth Krupinski, Victor Navarro, who is the one whose YouTube has that great video of the bird learning in the box, and Edward Wasserman. And that is their point at the end of this paper, is that, listen, we're not saying that every hospital needs a flock of pigeons. Unfortunately, we are not rehoming the birds. What they are doing, however, is they are looking at and theorizing and trying to identify, James, exactly what you said, the ways that the birds are looking at these images and how they're pulling out what is and is not a malignant tumor, so that it then can be taught, Edie, to learning machines and train AI. So this paper came out in 2015. It references a whole bunch of, well, not a whole bunch. It references a few other papers and books, which I thought were interesting, which were about specifically. There was like one from the 90s about how they like looked at pigeons and were starting already back in the 90s to think about like pigeons as a source for training learning models, basically. Like they had already kind of identified that as a thing there. And they're specifically like where this paper situates itself is saying, like, as learning models become a thing, the way that pigeons look at and learn images or identify images and parse them is going to be relevant.
Yeah, I mean, what they say about guiding basic vision research into feature saliency. Like,
Right.
what things in the image are the most indicative of diagnosis?
Right. Yeah,
Which
exactly.
is really interesting. It's really interesting because that is a problem that we run into.
Can you figure out what the pigeons are looking at?
Yeah, because even experts will have experts have a lot of trouble describing what it is, why they made a particular decision. And in fact, there's evidence that people often will make a decision and then after the fact, if they're asked, why did you make that decision? A lot of the time they will just come up with something. They'll tell themselves a story, but they don't actually have access to the reasoning.
There's a really interesting point in this paper where they talk about pulling out the images that the birds have trouble with and trying to identify why the birds have trouble, because that's how they're looking at this is like it's almost more interesting to them what images the birds as a group have trouble with, right?
Yeah.
And when they like talk to doctors essentially about how they diagnose that image, it is really interesting because the doctors will do something like, I think there was an anecdote in there about sort of like changing the lighting or like putting something behind the samples to make the blues appear more blue. And it's like, oh, interesting. Like you alter the sample in order to find out what's going on. So like these pigeons, like you would have just as much trouble seeing the difference that the pigeons did, but you can change your surroundings, which our bird in the box can't.
Interesting, yeah.
I'm going to need a couple pigeons and some eye tracking software.
And we're going to put a little hat on
I think
them.
that's what we need to do next is figure out what are the pigeons looking at.
Yeah.
Right? Like how are they getting so good at
I think
this?
the answer is that like they've sort of done this. This paper was done in 2015 before, in 2015 we certainly weren't seeing the widespread use of learning models that we do today. And I do want to make a point here, right?
True.
Where learning models aren't going away. Obviously, they are here, and they are going to be a part of our lives, and that cat is out of the bag. You can't put that toothpaste back in the tube, right? So the question now is, what are these things used for, right? Because as someone who works in the arts, both in board games and theater and all of these other things, I think it is ridiculous that we should use these incredible tools to do bad art for us, for example, right? Like this is actually an example of something that would be great for a learning model, right? Like they talk in this paper about how like we're taking highly trained people, doctors, who probably could be doing better things, and we're just having them look at hundreds of images, where if a learning model could do this part of it, like that would be great. That's what I want the robot to do. I want the learning models to do like the boring, physically taxing, terrible things. I've said it before, I will say it again. I don't know why everybody tries to sell me AI that's going to like get into my Photoshop and make my pictures for me. I don't want that. I want AI to go into TurboTax and do my taxes for me.
Yeah.
Do my taxes and let me do art.
Right.
Don't do my art and make me do more taxes.
Right. Yeah.
Yeah.
It's crazy.
Yeah, that's so real. And I think even, I don't know, I went even one step further in my thinking. And I think about the way that, I don't know, the last 150 years or so has gone. And I think I would love an alternate reality where we're just, like, we see that 4 pigeons do really well.
And we just get all the pigeons?
We just get a bunch of pigeons.
Yeah.
Because the fact, like, if we're saying that it's 99% accurate, the AI model is probably also 99% accurate. But if it's a large language model, it's running on a gigantic server someplace.
That's true. It's consuming hundreds of gallons of water,
drinking all of our water.
And like, these are not
Yeah.
one-to-one. They're not easy trade-offs, but like we can accept a robot doing it. But there's something about our ego that we cannot accept that 4 pigeons are going to do as good a job as my doctor. You know?
Right?
We can't accept that.
On a sort of tangentially related thought, sort of related thought here. This quote has been on the screen for a while now that Pat is sharing with us, and the only thing I can think while reading this is like, yeah, but I don't love the idea of rats sniffing my breath for tuberculosis, and I 100% do not want a dog to sniff my prostate.
And I'm telling you, that's an issue of pride. I'm telling you that you're wrong.
You got to get down with the rats and the dogs.
I don't
and
want
be the
that.
beast you were always meant to be.
We need to appreciate the abilities of our non-human kin. And let that dog sniff your butt.
I don't. No, thank you.
Okay.
Oh my god.
So where are we at?
I mean, this one's fascinating. This one is really fascinating. I can't get over how happy that pigeon was to click a screen for treats.
Yeah, do you want me to take us back to...
Oh, he was
He was
so
happy.
happy.
Excited. All of our listeners, please, we link everything as ever. But this YouTube video, he's like hopping from foot to foot, pounding on that screen, ready for those bars to come up.
He wants those treats.
Making a decision immediately. That's the other crazy thing. Is
Yeah, the bird looks at it for two...
Yeah.
Well, because, like, you know, with a doctor, they're like, oh, no, this is somebody's life in the balance. The bird doesn't have that context at all. That bird is like, there's a pellet.
yeah.
Give me
There's
treat.
a treat.
I
I'm
want
going to
the
go
pellet.
as fast
Give me
as
the pellet.
possible. I'm very good at getting treats. I'm a pigeon.
So let's scale this bad, Larry. Let's...
Oh my god.
Where are we putting this?
So it's pretty ridiculous, okay? Pretty ridiculous.
It's definitely ridiculous.
Here's the thing that I think makes it a little more complicated, is I think they pull a punch. And it is in the final paragraph. Pat, if you could pull that back up again. Because they are like...
How so?
They're like other animals with special perceptual skills have done this. We have shown that pigeons can be an effective, tractable, relevant, informative, statistically interpretable, and cost-effective medical image observers. If they had a little bit more courage to be a little bit more ridiculous, the next sentence would be, we should consider this. And that's not what they do. The last sentence is, they say...
No, in fact, they actively say they are not yet proposing.
They are not yet proposing not yet proposing this role for pigeons. That docks a point of ridiculous for me, because
It does.
as ridiculous as that would have been, they have the evidence. You know, they even if they had said
They
more,
could have said that.
They could have said that, and they had the evidence to do it, but they could not bring themselves to publish it that way.
They could not. It probably keeps them from attaining a 5 for that reason alone.
I think so.
I do want to. I do
Thusly
want to.
can only attain a 4.
I do want to argue that it is still a 4 because, at a base level premise, we're like,
Can pigeons diagnose cancer?
right? Because that's the thing. It's not even detect, right? Because they talk about these other animals that, like, you know, have senses of smell or whatever. They're like, can this pigeon look at our biopsy and tell us if it's bad or not?
Is this pigeon better than a first-year medical student? And
Yeah.
the answer is yes.
Yeah, in like 3 weeks.
In like 3 weeks.
The Mayo Clinic suddenly puts in an order for retired pigeon homing pigeons.
Okay, so that puts us at ridiculous 4.
Ridiculous 4. Shockingly, I think
Yeah.
research
Yeah,
may
that
also
sounds
be
right
a
to me.
4.
It's big, relevant research. It certainly contributes to a body of work.
Well, that's the thing. It certainly contributes to a body of work. It even contributes to multiple bodies of work. We're talking about cancer research. We're talking about AI and learning models. We're talking about the use of animals in diagnostic.
That's a lot.
Like, it touches on many things, and it doesn't get much more high impact than trying to figure out cancer.
Actually,
Yeah.
that's real. Yeah, the more I'm thinking about it too, because like even if we just we do that thing where we take it one step further, right? Even if we are ignoring the pigeons and just taking the data and just saying this will make us better at quickly and accurately identifying cancer, that's a life-saving change for someone that you know.
Yeah, that's pretty big.
Kind of big.
It's actually huge. I didn't actually fully think that through, but like, yeah.
I think I'm leaning to a 4, but this is the first one that is tempting me to a 5.
It is, and I can't believe that it's this one that's tempting us towards a 5.
I was sitting on 480, but I think you're you when you just say it like that, yeah, I do feel 5.
It's super important.
Yeah, actually.
Are we gonna give the pigeon a treat? Are we gonna give the pigeon a 5?
Hey, they did exactly what you wanted. They were good at diagnosing cancer better than doctors. We should give the flock the treat.
Oh
they
my
flock
God.
source the solution. We should give them the treat.
The flock source solution
All
to
right.
cancer gets a 5.
Ridiculous 4, research 5. Get these little pigeons tiny stethoscopes. We're putting them to work.
Who needs a nest? We're gonna buy him a house.
By the power vested in me by the state of California, I now pronounce you Dr. Flock.
God, the fact that it's 4, the fact that 4 pigeons is better than a doctor is crazy.
Four pigeons in a lab coat is better.
4 pigeons in a lab coat. That's the title of the episode. That's the title of the episode. It's 4 pigeons in a lab coat.
God, that rules.
But the fact that
what I love
I will say,
what I love about the
this
adage
article
you've
is
just
only
given
about.
me... Go for it.
Go ahead.
No, do your thing.
Your turn. No, you do your thing.
No way. No, you.
No, you. Okay. So